Welcome to this tutorial on Kotlin Coroutines. In this series, we'll explore how to write asynchronous code in Kotlin using coroutines, making your applications more responsive and efficient. Coroutines are one of the most powerful features in modern Kotlin development, and by the end of this tutorial, you'll understand how to use them effectively in your projects. So, what exactly are coroutines? Coroutines are lightweight threads that enable suspendable computations without blocking your application. Unlike traditional threads, coroutines are incredibly efficient. They're lightweight, meaning they consume minimal system resources. They can be suspended and resumed at any point during execution, allowing other tasks to run in the meantime. And here's the exciting part. You can run thousands of coroutines concurrently without overwhelming your system, something that would be impossible with regular threads. Let's compare traditional threads with coroutines to understand why coroutines are so valuable. Traditional threads are expensive to create, consuming significant memory and processor resources. They're limited by system resources, meaning you can only create a finite number before running into performance issues. And managing thread synchronization is complex and error-prone. On the other hand, coroutines have minimal overhead, making them much more efficient. You can launch thousands of them easily without worrying about resource constraints. And perhaps most importantly, coroutines allow you to write asynchronous code in a sequential, readable structure, avoiding callback hell and nested code complexity. Let's look at your first coroutine example. We start by importing the Kotlin Coroutines library. The main function uses run blocking, which is a coroutine builder that bridges regular blocking code with coroutines. Inside, we use the launch function to start a new coroutine. This coroutine calls delay for 1000 milliseconds, which suspends the coroutine without blocking the thread. After the delay, it prints world. Meanwhile, the main code continues and immediately prints hello. This demonstrates how coroutines can run concurrently, with hello appearing first, followed by world after the delay. Kotlin provides 3 key coroutine builders that you'll use frequently. First is launch, which is a fire and forget coroutine that returns a job object. Use launch when you want to start a coroutine but don't need a return value. Second is async, which returns a deferred object containing a result value. Use async when you need to perform asynchronous work and get a result back. Third is run blocking, which bridges blocking and non-blocking code. This is mainly used in main functions and tests to create a coroutine scope that blocks the current thread until all internal coroutines complete. Suspend functions are the building blocks of coroutines. These are special functions that can be paused and resumed without blocking threads. You define a suspend function using the suspend keyword before fun. In this example, fetchData is a suspend function that returns a string. It calls delay for 2000 milliseconds to simulate a long-running operation like a network request. The key difference from regular functions is that suspend functions can only be called from other suspend functions or from within a coroutine. This is what makes them safe and efficient for asynchronous programming. Every coroutine runs within a coroutine scope. A coroutine scope defines the lifecycle and context for your coroutines. It serves 3 important purposes. First, it controls coroutine execution boundaries, determining where and how long coroutines can run. Second, it manages structured concurrency, ensuring parent coroutines wait for their children to complete. And third, it ensures proper cancellation and cleanup, preventing memory leaks and ensuring resources are freed when the scope is destroyed. Understanding scopes is crucial for writing safe and efficient coroutine-based code. Coroutine dispatchers determine which thread or thread pool your coroutines run on. Kotlin provides 4 main dispatchers. Dispatchers.main is used for UI thread operations, perfect for updating user interfaces in Android applications. Dispatchers.io is optimized for input-output operations like network requests and disk operations, using a shared pool of threads. Dispatchers.default is designed for CPU-intensive computations like sorting large lists or processing data. And Dispatchers.unconfined starts the coroutine in the caller thread, but resumes in whatever thread the suspending function uses. Choosing the right dispatcher ensures your application remains responsive and efficient. Let's see how async and await work together for concurrent operations. This suspend function fetch user data uses Coroutine Scope to create a new scope. Inside, we launch two async coroutines. One calls getUser and the other calls getProfile. Both operations run concurrently, not sequentially. Then we use the await function on both deferred objects to retrieve their results. The key benefit here is that both network calls happen at the same time, rather than waiting for one to complete before starting the other. This can significantly reduce the total time needed to fetch data, making your application faster and more responsive. Let's recap what we've learned about Kotlin Coroutines. Coroutines are lightweight threads that allow efficient concurrent programming. Use suspend functions to write asynchronous code that can be paused and resumed. Use launch for fire and forget tasks where you don't need a return value. Use async with await when you need to perform concurrent operations and retrieve results. Dispatchers control the execution context, letting you specify which threads your coroutines run on. And coroutine scopes manage the lifecycle of your coroutines, ensuring proper cleanup and preventing memory leaks. With these fundamentals, you're ready to start building asynchronous applications with Kotlin Coroutines. Thank you for watching, and happy coding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.